Hey everyone, this is episode 5 of our JavaScript Interview Prep Series. Today we'll be talking about event loop. So imagine you are in a job interview. The interviewer gives you this code and asking about what will be the output. According to the most of the candidates, start, then timer will be printed, then promises, and then end. Right? This is what actually one by one. Or many of the students they used to think start, then end will be printed, then timer, and then promises. Okay, so both are wrong. Let's run and check. Start, end, promises, and then timeout. So here most of the developers are panic, but not you, because in this episode you will understand the JavaScript event loop so clearly that you never get wrong in this again. Stay with me till the end because I am going to show you why promises beat setTimeout every single time, a real life async bug that cost one company millions. So here's the simple truth. So JavaScript is a single threaded, right? So it runs one line at a time. But website do hundreds of things at once. Animation, API calls, timer. Then how does it happen? This all handle the event loop, the manager of our restaurant kitchen. So let's give you an example of, let's copy this one. So as you can see, let's give a very simple example. As you can see, this is our call stack, this is our web API, and this is event loop, and this is execution step, how one by one it was happening. And this is task queue, like one is the microtask queue, another is the macrotask queue. Imagine there was a restaurant kitchen, the safe is the call stack. The safe is the call stack. He cooks at a time one dishes. But better are the web APIs. Web APIs, what are the web APIs? Like setTimeout, fetch, DOM events. These all are the web APIs. And like the manager are the event loop. This is the event loop. This is only the manager. So what he keeps checking whether the safe are free or not. If safe is free, then he is taking the next dishes. Safe make the next dishes. So he's the manager. He is to manage. So that event loop does the same thing. Event loop constantly checking whether the call stack is empty or not. If it is empty, he will take that from our queue and he will push to the call stack. So this is the JS Flow website. This is a very good website for understanding all the JavaScript code. You can check it out. I will give you this link in the description box. So let's run this one and check how the things is happening. When our code actually runs this code, it went to there was one global execution context was created, right? And if you see in the execution step, and console.log was pushed to the call stack. Console.log pushed to the call stack. If you see here carefully, before the code was in the console dot was printed in the console, it was in the call stack. So once call stack run the console.log, it was printed here. So after printing, it was the popped up from our call stack. Okay. So the next step, it will take the our anonymous the function is created. Yeah, the setTimeout anonymous function was created because this is the anonymous function. As you can see, this is anonymous function. So the next step, it was pushed, the setTimeout pushed to the call stack. setTimeout now in the call stack. Once setTimeout runs, the web APIs check, yeah, this is a timer, so he has to put into the web API. Just even if it is in 0 second, but this is a timer, so it will go to the web API. As I told you, web API is like setTimeout, fetch, DOM interval, everything is in web API. So what they will do, our execution, like our event loop will check still, because now our call stack is global execution context was there, and the setTimeout is in the web API. So in the next step, when it was in web API, once the timer is ended, because it is in 0 second, it will not take much time. So it will push to our macrotask queue, which is the lower priority, which is known as normal queue also. So the next step, what it will happen, it will be popped up from our call stack, and it will be popped up from our call stack, and our promises will be now our code is pointing to the line number 4, and promises now in our call stack. So what is there in the promises? Promise.resolve. So universal promise is created with the fulfill, and promise resolved immediately, we just resolved immediately only. So now it was popped up from our call stack, and it was console.log was created. And as you can see, promise.then was there. In the promise.then, it came to our macrotask queue. If you see this one, it was came like for the setTimeout, it was in the macrotask queue, but for the promises, it was in the microtask queue, which is the higher priority. That is the reason. If you see the carefully, if you it was came to here, and our function call console.log, now our code is the line number 5. So the end was printed, as you can see here clearly. So once the line number 5 code was executed, because the microtask queue is in higher priority, so it will take to our event loop will constantly checking. As you can see, one task is pending. Event loop task is like gatekeeper. He is consistently checking that whether our call stack is empty or not. Once call stack is empty, it will take to this microtask queue, and it will pop up from here, and it will push to the call stack. As you can see, once promises were resolved, console.log promises is printed, it was took our microtask queue, and after that promises is resolved. So even if you are not getting this one, just go with jsflow.info and run this code once, and see carefully the whatever happened each step. Even if one step already executed, click the previous one. How each step, what are the steps happening? Global execution context was created, microtask queue was created or not, and after that it was popped into our call stack, right? I hope that you have understood this one. Now let's make it a little bit tricky. We'll go one step ahead. Now here setTimeout was there. As you already know how setTimeout works, now you have to tell me what will be the answer, or what will be the console.log. As you can see here, setTimeout was there, which is running in 0 millisecond, and we have promise.resolve, console.log promise 1 and promise 2. Let's see what happened. Let's run it and check. Promise 1, promise 2 and setTimeout. What happened? Why? Because each dot then create a new microtask. The event loop keep draining the entire microtask queue, or even touching the call stack queue. Let's go into JSFlow and copy and paste this same code, and let's run it and check how actually, we have to rerun once. Yes, as you can see here, it came to in the global, it came line number 1, and it's create a global execution context, and within that they checked, yes, it is in setTimeout. So they create the now in call stack setTimeout came, yes, it was there, and after that they checked, yes, we have to push to into our the setTimeout have a timer, so we have to put into web API. So yes, as expected, they put into web API, and they will remove from call stack now, and they will come to the next line. Yes, it was now removed from call stack, and as you can see now microtask queue, it was waiting. Now microtask queue, it was waiting just because in 0 millisecond, so it's quickly finishes their timer. So that's why it was came and it was waiting to the microtask queue, and one task is pending. Yes, as you know. Now here the trick is promise.resolve. They checked, yes, as you can see, it's create promise.resolve, which came into our call stack. Yes, and now it's running actually, as you can see here, immediately invoked, immediately resolved that one, promise 1. Let's check. Yes, as you can see, it was removed from there, and it was getting, yes, as you can see here, that promise 1 is in call stack, and promise.resolve remove from call stack, and there was an anonymous function was there, so that is promise.then, and that is also pending, just because promise is an asynchronous task, so which need to be waited. Once they will give a fulfilled, then only we have to console. So that's the reason here actually, if you see carefully, promise.then callback executes, and it's registered into callback chain, and then it was removed from call stack, and then it returned the pending one just because it is not yet created. Then anonymous function was created, that next one. The anonymous function was created, but here is the main thing is, it both are in the like queue, both are in the queue. One is the microtask queue, it is inside setTimeout, but the macrotask queue, it is an, but both in the queue. Macrotask queue, as you can see, setTimeout, but microtask queue is in the like promises was there. But here two tasks was pending, as you can see if you carefully. So two tasks was pending, but once this will be running, once the second one, the dot then was running, promise chain was registered, as you can see here. This one, it will push to our microtask queue if you see carefully. Yes, that is what, just because it is in chain. If you see now, event loop starting 0 phase process callback queue. If you carefully see, timer process completed, event loop phase 1 process all. Yes, now they take the both callback. They took the both callback, and there is an anonymous function console.log promise 1, as now it will be printed promise 1. The promise was getting printed. Yes, promise was, and it will be popped up from the anonymous function, and again they will come to the next one. Again they will come to the next one. They are waiting. Yes, again they will come to the next one, but still our microtask queue is waiting. Our setTimeout is waiting, but just because he is in lower priority, so they just ignore that one. The event loop is ignoring the macrotask queue. Wait, you have to wait, because our high priority person is waiting. So now it was printed promise 1 and promise 2, and it was, if you see, event loop is processing and waiting for the task. Yes, now anonymous function came, console.log, setTimeout will be printed here. Yes, and now it will be popped up from call stack, anonymous function will be also popped up. So that is the reason, basically it was from promise 1, promise 2, and setTimeout was printed like that way. Okay, the real life async bug, what we have told initially only, as you can, I hope you can see this one. Yes, there is one developer was there, he used setTimeout to update UI element after an API call, this one. Okay, let's take this one and we will paste this one, so it will be easy. There is one, he used to update in setTimeout. He used to put one timer, and he's thinking that will be run immediately. He thinks after start this will be run, because line by line JavaScript runs line by line. So he thinks like that way. But a promise inside the same code base, this one, it was finished fast. So UI updated too early, showing wrong data, and that cost company million to customer refund, because it is a wrong data and buggy data. How it was happening actually? So according to the developer, first start will be printed, then updating UI with the old data will be printed, and then the correct data will be printed, or first start will be printed and end will be printed, then this will happen. But both are wrong only, whatever happened. If we run this one, as you can see, first start is printed, then end is printed, then the correct data before, because the setTimeout have the lower priority, as we can already show right now. The promises have the higher priority, even if it is waiting in the macro task queue. The event loop doesn't care. Event loop will not see only him if our high priority person is waiting in the micro task queue. As we already showed in the JS Flow website, you can also explore this one, so you'll have a better understanding. So now let's move this one, and we will give you one async await twist question. This is also most very important, and most of the interviewer used to ask this one. There is one async was there. This is the test function, and there is one await was there where promise.resolve will be happened and console.log outside will be there. So try to guess what will be the order of this console, which one will be first and which one will be last. If you guessed, I hope you guessed it. If you not, please pause and think of it. Okay, now let's run and check actually why it was coming like that. Inside function, this is in general first, line by line. Okay, yes, but promise is waiting, right? Like first inside function was printed, then because this is normal console, so it should print for second, then it should print the third, but actually it was not. This await, this is the main magic here. If you see this one, await pauses inside that function and put the rest all the micro task queue. If you see this one, console.log inside function was printed, and the second line await was there. Await used to pause inside that function. Once the promise will be resolved, they will wait, they will keep that execution to pauses, but that will be into that function only, that will be not waited the entire code, that then our app will be not working the entire, if the code base is just paused. No, it will be not like that. It will be that entire that function only, whichever function they are doing. So outside of the function they doesn't care. So that's why after running this console.log inside function, our call stack will remove this test function and it will move to our line number console.log outside function. Once this is printed, meanwhile it will be resolved. So then it came to our microtask queue, and after that they will give that access to line number 23, and it will be after await. I hope you understood today's episode, like the event loop, how behind the scenes works, each step. If you not understood, just go and paste your code into JSFlow. This website is free, so you can explore this one. Thank you so much for watching this video. If this video helps you, please hit the like button and subscribe to our channel. We'll see you in the next episode.